Hello, and welcome back to the Rawkode Academy. This is Rawkode Live, and I am your host, Rawkode. I've now said my name 3 times in 10 seconds, and I hate it. Today, we are taking a look at an open source project to bring continuous profiling to everyone. The project is called Parca, and we are joined by the CEO. Hey, I turned that little video off. All right, I'm just going to ignore it. I'm going to pop over here where I'm just throw myself off now. I'm joined by the CEO and founder Polar Signals, Frederick Branchik. Hey man, how's it going?
Hey, pretty good.
See, I say at the start, don't worry if things go wrong. It happens all the time. It's usually me. In fact, it's always me. I just break stuff every single episode. So thank you for joining us today. For anyone who's not familiar with yourself, can you give us just a little bit of a hello and an introduction, and then we'll take it from there.
Of course. First of all, thank you for having me. I'm Frederick. I founded Polar Signals. I've been part of the cloud native ecosystem for 6-7 years. I was part of I joined the Prometheus team in 2016 as a maintainer. Basically, I think a few months after Prometheus had joined as the second CNCF project of all time. I've been around for a while. And as I said, Prometheus was kind of my entry point, but I kind of was in charge for all things that connected Prometheus and Kubernetes. And so to this day, I'm actually still maintainer for the Kubernetes integrations in Prometheus. And over time, I co-created, but also eventually became the tech lead of the special interest group for instrumentation in Kubernetes. After I think 4 or 5 years of service, I recently handed off that position to make room for some new blood. But kind of that intersection of Prometheus, or more generally observability and Kubernetes, has been my thing for a very long time. I originally started doing all of this when I joined CoreOS. I don't know if people still remember CoreOS, but after the CoreOS acquisition by Red Hat, I kind of stuck around at Red Hat for a while. I became architect for all things observability. And kind of long story short is that I eventually quit Red Hat to found Polar Signals because I felt like there was something about continuous profiling that was worth pursuing.
Awesome. That's a really good overview of your history. You've got one of those usernames and faces that, because you were so active in the Prometheus ecosystem and community, that I see your little avatar on GitHub all the time, and then you started showing up on doing a lot of KubeCon talks and other talks, talking about observability, instrumentation. I think the Prometheus operator era as well. So it's great to have you on the show, and I'm really looking forward to taking a look at Parca and what you've been working on for the last little while. So I guess, I've said that Parca brings continuous profiling to everyone, but could we dive into that a little bit more and just understand what is Parca, what are its main components, and what do people get out of deploying Parca to their infrastructure?
Yeah, maybe before we dive into Parca as a project itself, maybe let's talk a little bit about continuous profiling, because I think it's still an emerging methodology. So while hyperscalers have been doing this strategy for almost a decade, it was pretty inaccessible to most other companies, and that is what we're trying to fix with the Parca project. But continuous profiling in its essence is basically that we always profile absolutely everything in our infrastructure. And this is useful because of the same reasons why we generally do profiling of our software, right? We want to understand where our resources spent, where's my CPU time spent, where is my memory being spent, where are my memory allocations happening, or really you can think of profiling data as anything possible that you can possibly think of, where you can you have a stack trace and you attach a number to it. That's basically what a profile is, right? Just a collection of many stack traces with a number attached to it. In the case of a CPU profile, it's how often have we seen this particular stack trace, and we translate that to time spent in that function. And so, as I said, CPU profiles is something that is really interesting because CPU tends to be the most expensive thing in cloud environments, but memory is certainly a next contender, or network I/O, or like disk I/O. All of these are things that contribute to cost, and this is kind of a good segue to why do people want to do this? And the most common answer to that is people want to optimize their cloud builds, and that's exactly why companies like Google have been doing this kind of methodology for over a decade. They kind of identified, and I think it's obvious once you say it, but once you have that data about where your resources are being spent down to the line number, right? Like that's how granular profiling data is. You can actually do something about it. If you don't have that data, you just don't know where to start. And continuous profiling, as I said, is the methodology of just always doing profiling. And there are a couple of things involved in actually making that possible, because maybe this is something that's already a question that was queued up in your head. Typically when we talk about or think about profiling, people immediately think about overhead of profiling,
Definitely.
right? And they want to know, like, how much is doing this actually going to cost me, right? And the answer to that is essentially we've developed a couple of strategies to reduce profiling overhead, so that we can always do this. And there are kind of two main things that are contributors to this. One is the type of profiling that we do, and what we do is called sampling profiling. And that essentially, we can think of it as how often are we looking at the current stack traces, let's say, for a CPU profile. And obviously, the more often we sample those stack traces, the higher the overhead is going to be. But we found that for like looking 100 times per second is still like offers enough granularity at very low overhead, something less than 1% of overhead of a CPU core. And the reality is, once you have this type of data, almost everyone we find has very easy optimization potential of like 10 to 30% of their infrastructure. So the trade-off is, am I spending 1% overhead to gain 10 to 30% optimization? I think that's an easy calculation to make, right?
Yep, definitely. There was a lot of information there, so thank you for getting into that. And you're right. One of the things that I had on the back of my head was like, what am I paying for this for my own infrastructure? And you said the overhead is, I don't think you said negligible, but I'm going to throw that word out there, to a certain point where it's not that much because of your sampling strategy, which I think is really interesting, because I think the more visibility people can have into what's running in their clusters, it can answer two of the hardest questions that I think people have in the Kubernetes space. Like, I don't think there's been a conference or a user group that I've went to where someone hasn't asked me, how do I set resource constraints on my pod? I'm like, yeah, you have to profile your application and understand what normal looks like. And it's this quite a scary thing. I don't think a lot of people have profiled their applications before, well, probably ever. And the second question is, how do I debug garbage collection and memory leaks and other things? And again, you're back to the profiler, and I was like, I'm sorry, you're going to have to learn this stuff eventually. So it's nice to see that Parca can come into this space and do the continuous thing in a way that isn't going to cause too much overhead and just increase that visibility without it being too daunting, too scary, too nerve-wracking. Like, we're all very careful, I hope, about what we deploy to production. And there's my next question. Can I run Parca in my production infrastructure? And is that something that is encouraged?
Yeah, I mean it's really just like any other observability data. You can certainly run it in pre-production environments or something, and we encourage that as well. Um, but in a similar line, on a similar note, as like your metrics are just never going to behave the same way in your local dev environment or even a staging cluster. It's always going to be different in production, and so you're going to always have to measure these things in production.
Yeah, definitely. If you're trying to work out what normal looks like in a staging environment, it's never going to correlate to what you have in your real production environment. I couldn't agree more.
Yeah. And in terms of like how production ready is this like open source project, let's say, like I think it should be at least a little bit taken with a grain of salt because it is a very young project, right? Like it's existed for maybe a couple of months, but it's every week. We have an entire company working on this and improving it, right? Like every week it improves drastically from literally every dimension. Like on overhead, it continues to improve. On the storage, it continues to improve. Yeah, just on every really on every dimension, which kind of I think is also a good point where we can talk about what you said earlier, what makes up the Parca project, right? Because there are actually a couple of moving components that I think are good to understand. So the Parca project, largely you can think of it as having two components, the server and the agent, or the collector, you could say as well. The agent, the collector, is the thing that actually does the profiling part. It's the thing that captures the raw data and then batches it up essentially, and then sends that to the server, which then stores it, and where you can also query it through its API and UI that is all integrated. It's all very inspired, at least the server part is very inspired by Prometheus. It's probably not much of a surprise given my background. Like we really focused on having this extremely simple, really great first experience where it's a single statically linked binary. All the container images exist. There are like manifests available for Kubernetes. Hopefully, your first interaction with the project is very, very smooth and very simple.
Sweet. Well, we're going to take a look at it in just 1 second. Before we do that, I'll throw one more question at you. Like, it's an easy question, no stress or anything like that. But I feel like we're in a really great position these days in the cloud native ecosystem, where Kubernetes is almost ubiquitous with people. Maybe it's a good thing, depending on who you're talking to. But we're at a stage where it's ubiquitous. Almost everybody has a metric server. Everybody's got a Prometheus. Everybody is doing some monitoring. We're seeing a bit of a push with observability and people looking at distributed tracing, etc. Do you feel that Parca is one of these components that if you have a production cluster, then Parca should just be installed? Like, are we looking at a project here that we're saying to people, if you have production infrastructure and it's Kubernetes based, yes, you must have this installed, like next to your Prometheus?
Absolutely. The whole point of, or the reason that actually motivated me to found an entire company around this is entirely based on the premise that I believe that this type of data is completely complementary to your existing observability stack. As a matter of fact, I didn't know it back then, but I think the seed for all of this was planted in a like an invited keynote that I gave at KubeCon in Barcelona in 2019, where Tom Wilkie and I kind of gave, he's the VP of product at Grafana now. He and I kind of gave an, like some guesses, let's say, what the future holds for observability. And part of that was where I predicted that I thought that continuous profiling was going to become a major player in the observability world, simply because it, just like any other observability type of data, it gives you a unique kind of insight into your running application. It's unlike metrics, it's unlike tracing. It's just like metrics and tracing are complementary to each other, continuous profiling data is also complementary to those.
Sweet. I love that. You make a prediction and then go out on a multi-year journey to prove the prediction correct yourself.
It's as they say, like, if you want to predict the future, you got to build it yourself.
Yeah, perfect. That's awesome. Okay, so we're going to jump to the screen share in just 1 second. We do have a question from the audience, so I'll pop that up on the screen and read that out. But Avinash is asking, can Parca also collect metrics and be used for dashboards and stuff? Or do we need separate monitoring agent?
So it's not exactly like metrics, but you can think of it as a super highly granular CPU metric, for example. Right now, you probably only have CPU being measured on a per process basis. Maybe if you're talking about Kubernetes, maybe on a per container basis or on a per pod basis. And in this case, we would actually be getting data down to the line number and not just to the process, but also with process metadata. And we'll see in a second just how similar the experience actually is to Prometheus, because the entire like labeling strategy of Parca is very intentionally based on what Prometheus does, and hopefully it'll all feel natural to someone who's already used Prometheus before.
All right, let's get straight over to the screen share and get Parca deployed in. Here we go. So this is parca.dev. And we have the website. We've got some basic instructions. We have prepared up front a Civo K3s cluster. This has nothing installed. It wasn't installed out of the box by Civo. So we're starting completely from a fresh. And we'll jump back over here. So, I mean, I could ask what the next step is, but I'm going to assume it is to install Parca. Yes.
Yeah.
Step one's always the easy one. After that, I get a little bit, I'm not as confident with my predictions. But so this is, let me zoom in on this actually. Just we've got some really simple instructions here for Kubernetes. We're not using Minikube, so I can skip this. We're deploying Parca to its own namespace. I assume that's the preferred approach. And then we deploy the two components that you mentioned just a few moments ago, the Parca server and a Parca agent. I'm assuming this just runs as a daemon set. This is a deployment. And by magic, the thing just starts working.
Yeah.
What I'm curious about is, like, when I deploy these, has the profiling started already?
Yeah, so that's a great question. The Parca agent, as we said previously, is the thing that does the profiling, and it actually starts to automatically profile absolutely every container in your Kubernetes cluster. It kind of discovers everything that's there, and it uses eBPF to attach an eBPF program to each of those containers. And that's essentially how the entire construct of the profilers are built.
You said the magic word. Like, I can't believe we're 19 minutes in and eBPF has just popped up. But yeah, we're seeing such a crazy adoption of that right now. It just seems to be solving a lot of these observability and performance, not problems, but questions that people have.
It's funny because when we actually founded Polar Signals, we didn't really want to concern ourselves with the collection side of the problem. We felt like the majority of the value was in storing and querying this data in a useful way. But we pretty quickly realized that we were going to run into kind of two problems. The first one was the overhead problem, which we kind of already talked about, but eBPF kind of adds an additional benefit here because everything runs in kernel, and because we can collect exactly the amount of data that we need in exactly the format that we want it in. It allows us to do the profiling at actually an order of magnitude less than quote unquote traditional profiling techniques. And there are a couple of things that maybe we can get into later that kind of make up this strategy. But yeah, eBPF has definitely been a really amazing fit. And just the nature of how eBPF works makes it really simple for us to attach these profilers to every container on a host, because eBPF is literally able to do anything or inspect anything on the host, right?
Yeah, we got that question from Moz, right? And just as we started talking about eBPF, but Moz was curious if it used eBPF, and I hope that we've answered that for you there, Moz.
Yeah.
Sweet. So we've deployed the agent, we've deployed the daemon set, the server and the daemon set, which is the agent. Like, what is the way that we interact with Parca? Should I go back to the docs, or should I just start guessing? Like,
I mean, you can hit the like Parca in Kubernetes tutorial 5 minutes button, and you'll get the entire basically manuscript of what we're what we're doing here. But you can check out here. You see the like a port forward. We don't make an opinion of we don't want to take an opinion of how people are going to expose this. You can put an Ingest here, or
yeah,
I don't know, whatever your preferred way is, right? So here we're just telling people to do the port forward.
All right. Well, we have a 3-node cluster, so we had 3 agents. We've got the server. We could do a port forward to the service on 7070. And let's see.
Okay.
Yeah, we have Parca.
It worked. The first feature that's always the most important to people is on the top right. You can see the little toggle for dark mode. It was actually one of the first feature requests that we got. So yeah, definitely important. But no,
it's always nice
from
when
here,
you go to a blog, though, right? And you see that little sun and moon in the top corner, and you're like, oh, good, I can set my own preference. Like, I think as developers, we get a lot of pleasure from the simple things like that. So it's good to see.
Yeah. So when you start, and this is actually something that we're actively trying to improve, that you don't need to know how to use this just yet, that you immediately see some data. But for now, this is how it works. And you start by selecting the type of profile that you want to see. And right now, the Parca agent only supports CPU profiling. We're going to be adding more of this, but the entire Parca project is actually based around an open standard called pprof. This was a format that Google had originally created for representing profiling data, essentially. And anything that is pprof formatted can be written to the Parca storage. And so in this case, we're only sending CPU samples, but there are integrations. For example, the Go runtime itself has support for various types of profiling, like memory profiling, Go routine profiling, and you can also ingest those profiles into Parca. In this case, we are only running the Parca agent, though.
Okay, so I just select on CPU samples here.
Yeah.
And then
And you could already hit search at this point, and you'll start to see some data.
Yeah, I like a graph. Nice.
So now we can already see some similarities to Prometheus here. If you hover over a dot, for example, you'll see that there are like labels attached to this series of profiles. So here we have the Parca container itself and the ID of it, its namespace, the node it's running on, and the pod. And you can hover over each of them, and whenever you're closest to a point, it'll tell you what container we're looking at. You can also, while you hover over something, maybe it's maybe a little small for the audience to see, but it says hold shift and click a label to add to query. So if you hold shift while you're hovering, you can now click one of these, let's say the Parca namespace, for example. Then it filters everything down, and you can see that our query was updated in the query bar. and now we're only seeing processes from the Parca namespace.
Cool.
And so far, we're only seeing metrics, basically, right? But we actually want to see profiling data. So what we could do now is any of the dots that you were hovering over, once you click them, you'll see, and you need to scroll down, then we'll see
Oh, there we
a
go.
flame graph.
So this is showing me, I wish I should have paid more attention to what I was clicking on. I think I clicked on this. So this is the Parca container. So this is actually the Parca server container. Okay. And
Yeah,
this is
the
all
Parca server itself.
all the functions being called within that application.
Yes, exactly. At that point in time. So
at that point in time,
the profiles are always taken over a 10-second interval. And so within those 10 seconds of which the profile of the profile's timestamp, these are the things that were being executed during that time. And there's something that I've been incredibly excited about ever since we first implemented this. If you scroll up, you can see that there's a compare button next to the search button in the bar. Yeah. So what this now does is it should open there we go. So what we can now do is we can compare two profiles in their points of time. So for example, on the left hand side, select one of the Parca profiles that isn't a peak, maybe from the green one, that one, and then on the other one select the one at the peak just after that, or that peak, it doesn't really matter. And now you can see exactly what was worse in the comparison of these two profiles. In this case, the comparison was quite drastic, so we're seeing a lot of red, right? But if it's more nuanced, we can see exactly what was different. And again, in this case, it's quite drastic, so all of the red is pretty dark, but it's actually shades of red that are telling you what got how much worse.
So I'm curious, like I'm an application developer, I'm shipping multiple times per day. Would this compare feature allow me to compare a standard profile from one version against a profile in the new version I've shipped to see if I've got performance gains or maybe things have gotten worse since I modified it?
I'm glad you asked. For answering that question, let's take a step back and talk about one more thing that kind of makes continuous profiling so great. And for that, if you just hit profiles at the top, this kind of just resets our query. So if you select CPU profiles again, and then maybe filter just down to the Parca container. If you want, you can hit search and then click the label, or you can do a label search. Yeah. So now, other than compare and search, what we're seeing in the search bar, there's also merge. And what this does is it takes all the points in time that we've collected over the entire time of this process, and it compiles everything into a single report. And this is really, really cool because not only does it tell us where CPU time was spent at a single point in time, but actually it tells us statistically over the entire lifetime of this process where CPU time was being spent. And so the consequence of that is that once we look at that report and we can optimize something in that holistic report of our entire process's lifetime, if we can optimize something from that, we will actually reduce CPU time of the entire process's lifetime, right? So that's how we'll actually do significant cost savings.
Okay, so should I click the merge button?
Yeah, hit it. So now we see all of the data of the entire time that the Parca process has been alive, and we can explore where that CPU time was being spent, as opposed to just a single 10-second profiling time.
Cool. I like that. That's very interesting.
And now coming back to the question that you had.
Well, can I ask a really
your question was to come back to your question, which was, can I essentially compare two versions after I kind of deployed them, right?
Yes. Yeah.
And the answer to that is yes, but not only a single point in time, but you can actually compare the entirety of two versions. So not just this process at this time and this process at that time, but no, you can actually merge all of the data of a single version of a program and compare those two versions. So finally, we'll be able to answer down to the line number what was different. Why is this thing using more CPU now after I deployed it compared to previously, or why did it get better, right? All of these things that previously, as engineers, we were kind of guessing. Now we actually have the answers.
All right, awesome. This is really cool. I think this is an absolute game changer. Now, we've got one question from Russell in the chat, which we'll tackle in a minute. But I also want to tackle something, like just one of the really simple things here, that not everyone may be familiar with this graph and what this is displaying and what it means and why things are duplicated. Could you give us the 101 for this flame graph and what that means?
Yeah, so as you already said, this visualization is called a flame graph. And the way that we read it is that this is called an icicle graph, which is the upside down version of the flame graph. The flame graph is built from bottom up, like a flame, right? But the icicle graph is icicles hanging from the ceiling, just like the one that we're seeing here.
Today I learned.
Yeah, I created the brand Polar Signals without even knowing this, and then afterwards was like like a happy little accident. But yeah, coming back to how to read this, essentially the very top bar, the root, describes all CPU time that we're looking at. And then every span that we're looking at underneath it is relative to that total. And so if there is a span in here that we can optimize, it means that the width of it will that will be the effect that it will have on the entirety of our program. So let's say one of the larger spans that we see in the middle here, if we're able to optimize that, we can actually, and you can hover over it, it tells you the percentage as well. If we can optimize that away, in this case it's 90%, but right, the further we go down, the less it gets because it's kind of cumulative. But if we can optimize this one away, for example, we would be saving 36% of our entire process. And the more we do this, the more effect we see on our cloud bill. But there are actually a couple of other use cases that I think are also good to talk about when we think about profiling or continuous profiling. Obviously, cost savings is one that we've talked about several times by now. But I think there are kind of two more that a lot of people find very compelling. The kind of helping you with latency optimizations, because latency tends to be, we tend to be able to, if we're this advanced, we may be able to detect where latency problems exist in our system with tracing data. But tracing data is actually very high level, right? It doesn't tell us anything about the lines of code that we need to optimize. Yep. Combining that with profiling data is actually incredibly powerful. And we've worked with like e-commerce companies that are optimizing their latency through this type of data. And if you might know, e-commerce companies have this kind of target to have every interaction in their system be less than 100 milliseconds, because that drives conversion, because we humans like things to feel instant, and that means that we're more likely to purchase something on a website. So that's kind of, in the grand scheme, that's use case number 2, and it tends to be actually a much bigger motivator for companies to make more money than just to save money, right? But go ahead.
Would it be fair to say, we're talking about cloud native and microservices, hopefully that people watching have a little bit of experience with distributed tracing. And like I said, it gives you the latency response times from service to service communication. Is it fair to think of profiling as tracing at the function level, exposing individually within services what is actually happening on that call stack?
Yeah, that is entirely accurate. The difference is that it's not across services; it's only within a process. But we're actually working on a couple of correlation techniques so that we can tell you, for example, all of the CPU time that was spent with a particular trace, for example, so that we can jump from a trace to profiling data. This is not something that works yet, but we have a couple of strategies that we're exploring to make something like that work. But yeah, and then the last use case that I was talking about is kind of, I think we sort of touched on it already, but I think it can be generalized as incident response, right? Because we have this data of what our processes are executing down to the line number, we can actually answer some of the questions that we as engineers have kind of, or at least I myself have been asking myself ever since before I had a tool like this, which is like, why was my process spending CPU time, or like had a CPU spike here and not here? And almost always, as you said earlier, it's GC, garbage collection. But yeah, sometimes it's more surprising than that. Or with memory, right? Like, why did my process use more memory at this point in time versus this other point in time?
Yes, definitely. All right, let's tackle the questions we have in the chat, and then we'll jump back to our demo here. And we got a hello, just done with the Parca office hours from Matthias. We got, okay, question for Russell. Did you say it profiles everything, i.e. the API server? And if so, does that work on cloud-hosted Kubernetes instances where the control plane is managed by the cloud vendor?
So probably for most of the cloud vendors that you're thinking of, no, because we can't get the Parca agent to get deployed on the wherever the API server runs. Basically, as long as we can get the Parca agent to be on the same host as something, it will be able to profile it. As a matter of fact, we're actually thinking about a couple of strategies where we can expand the things that we're profiling to not just be the containers on a system, but actually every process on that system. Because I think it's kind of obvious once we say it, but there can be other interactions with processes on a host that are not running in containers, right? Maybe they're systemd units, or maybe they're not running in C groups at all. So yeah, hopefully that answers the question.
Yeah, I think so. We also got another one from Moz. Can Parca compare the CPU time consumed by a specific function run on two different containers or different nodes?
Yes, absolutely. That's exactly what the compare functionality does. We're also working on being able to filter down the stack traces to not only compare by container or by process, but actually down to the stack trace, so that you can say, I only want to see data about this one function, and then you can compare it exactly the way that it was phrased in the question. Right now, you would compare two whole profiles, and you would need to find the specific function that you're looking for, but we're absolutely working on this specific use case already to support it even better.
Awesome, thank you. And we'll tackle this last one that came in from Umanga. Do we only get CPU profiles?
So great question. So I think I mentioned it earlier very briefly, but the entire Parca project is based around the open standard pprof. And any pprof formatted profile can be written to the Parca storage and can be visualized and analyzed in the same way as we're doing with this data. So as a matter of fact, the Parca Agent also produces pprof compatible profiles and then sends those to the Parca storage. And so as long as you can produce profiling data in the pprof format, you can write it continuously to the Parca storage. So there are lots of profilers out there. As I said earlier, the Go runtime has support for memory profiling, for allocation profiling, for threads being created, for Go routines, for mutex contention, for a whole lot of things. And all of those can be written to the Parca storage and can be analyzed in the same way.
So these are profiles that you plan to support in Parca. They're just not quite there yet.
So there are kind of two ways to ingest data today into Parca. The first one is pushing the data, and that is exactly what the Parca agent does. Whenever it has a profile ready, it just sends it to the Parca storage. And the Parca server actually also supports scraping profiles in the same way. You can think of it very similar to what Prometheus does, where Prometheus has its metrics endpoint and it scrapes the metrics from that endpoint every 15 seconds. Parca can actually do exactly the same thing with pprof formatted profiles. And so I think actually this might be a great time to have a look at that. What you can do is you could go back to the parca.dev website, and we can switch from the Kubernetes deployment to the binary, because then we can just have Parca scrape itself, because Parca is instrumented with a whole lot of profiling, and then we can have a look at those profiles as well.
Yeah, I think that's quite. I don't want to make too many assumptions, but I think it's quite normal in the Go ecosystem, right, to have pprof embedded into your binary. I remember when I was working on InfluxDB, we had the debug/pprof endpoint, which exposed a whole bunch of information. And you're saying that Parca can just consume that right away if you tell it where it is.
Exactly. Yeah.
Okay. All right. So let's jump back over here. So if I go back to the start and the binary one.
Yeah.
Is this going to work on a M1 Mac?
That is a great question.
Let's find out is the answer.
I do not think so.
I think it is.
That looks like it works. Amazing.
Nice. All right.
Great.
So now we get the basic configuration and just run Parca. Do you mind if I just quickly take a look at this?
Yeah, go ahead.
All right. So, wow, it looks like a Prometheus config. No surprise.
It literally reuses Prometheus code.
All right, so you just define the scrape config. So I'm assuming these targets could be anywhere I know there's a container, a pod, an application that exposes pprof endpoints, and Parca just pulls them in, right? Okay. And I'm assuming I just go to 7070 localhost, and
yeah,
we still have that open. So let's just refresh. Is this my old one? I think maybe.
Yeah, that.
Not seeing what I expected to see.
Yeah, this still looks like our Civo cluster. Yeah, this is too much data. That's definitely not.
But I'm not port forwarded anymore. I'm confused. Am I? No. Oh, I am. So this.
Is this maybe a virtual machine of some sort?
No. Well, my port forward was still running, so I actually would have expected an error message there.
Yeah, I did as well.
Oh, there we go.
Ah, okay, yeah, now it works. Yeah, so now you can see these are all the types of profiles that Parca scrapes from itself.
Yeah, so
So
that
I think like memory in use bytes is a nice one to look at.
search.
Let's give it a couple of seconds because it's not writing a whole lot of data, right? Like it's only about itself.
Yeah. So what was the? Do we define a scrape interval in that config? I wasn't.
Yes.
Yeah. Okay. I don't have my history there. So that's just I can tell it to scrape profiles on a more regular cadence to kind of just boost that up. Is that worth
Yeah.
doing, or do you think we just wait 10 seconds or?
You can just hit search again, and there might already be.
Yeah. There we go.
So now you could do the compare, and we could figure out exactly why this jump happened, right? Yeah, and we can see Badger created a bunch of skip lists.
Yep. New skip list. Well, I'm not sure what I did there.
So you're scoping essentially this is essentially interacting with the flame graph, and once you found something that you're interested in, you can see on the left hand side, for example, there are a couple of spans that are too small to read. You can click on one of those and it'll expand, and then you'll see all of the rest of its child nodes.
Okay.
And essentially everything that's like faded out is the part that we're kind of zooming in on, right? And from there on, the root essentially becomes whatever we clicked on.
Okay. Does it like this is a runtime dot do init function? Like, can I find out how many times this was called? Like, if I had maybe a recursive function that was going a bit wild in my application, is Parca, would I be able to show that in some way, or would it just be I would see it called lots on the call graph?
Yeah. So this depends a little bit on the profiler itself. Typically, profilers have some sort of limit on the stack depth. This tends to be 64 frames, something like that. So that's how often you would see it repeated, and then at some point it would stop if it's like endlessly recursive. Yeah.
Okay, so I want to make sure that I understand this right. So we're using a different profile because it's being scraped over HTTP. We're looking at the memory and use bytes. We can see the graph, which is showing us how much memory was allocated at 2 different points, which is great. We have these red things, which I'm assuming is telling me that these functions are consuming memory on the stack.
Mm-hmm.
All right, okay. I mean, is there a size? Like, I see we have a figure here. I know that we're using 120 meg, but does it show me more specifically which one of these functions is the bad actor here? If that was, again, a memory leak or something else?
Yeah. So you always want to look at the deepest span that doesn't have any children anymore. So we can actually tell here that new skip list is actually the thing that allocated the memory here. So if we optimized new skip list, in this case, we're intentionally pre-allocating memory, so it's not actually a bad thing. But let's say it was. If we optimized new skip list to, if it was truly possible to just not do this at all, we would actually save 70% of our memory, almost, or 67.81% of our memory, right?
Okay.
So yeah, and I think maybe this is a bug or we need to update the version. But we see the cumulative and the difference number here. We know actually that this data that we're looking at is bytes. So it should be formatting this as, I want to say this is like 87 megabytes or something, but maybe I'm wrong.
No, I think that's right based on what we've seen here. 40 to 120. So yeah, you're pretty much spot on.
So yeah, it looks like in the graph it's working. Maybe we have some bug in the in the front end about the hover state.
Okay. I don't mean to put you on the spot, but would you want to give us like the TLDR for these different profiles and maybe what they're useful for to people?
Yeah, absolutely. So these are very specific to Go, right? These are profilers that are built directly into the Go runtime. So these are definitely going to differ for different languages, different runtimes. But I think they're still really useful and interesting to know. So block contention, basically, hopefully the descriptions of each of the profiles underneath are descriptive enough. But essentially, whenever we have a blocking primitive being called, that's when we record that stack trace so that we understand where in what paths of our program is our program being stopped and can no longer do something. And in the Go case, this is actually particularly interesting because the Go runtime tries to move Go routines around to prevent Go routines from actually, or threads from actually blocking. So this is a really useful one to know if for some reason Go routines keep being scheduled onto different threads all of the time, which would create a performance problem. Go routines being created, definitely a very easy mistake to make, and certainly in the Prometheus project, we've like fallen into that trap many times where we leak Go routines, we just keep creating them, they never end. And a Go routine means we create a new stack every time, which ends up costing memory. And then we'll eventually see it in both our Go routine profile as well as our memory in use bytes profile, that something is using a bunch of memory and could end up being the Go routines being created. The next one is memory allocations. So we need to differentiate here. The one that we were looking at previously was the heap size. So how much memory is currently in use, right? Like how much, when we look at top or something, how much of that, how much memory are we using currently? And then allocations are how much memory has been allocated over the entire lifetime of our process. And again, this is a really useful thing to understand because allocations tend to be where we spend a lot of our CPU time. It's definitely a generalization, but a lot of the optimizations that we see are simply pre-allocating some memory instead of allocating them in small bytes, um, like one after another. Then memory in use we kind of looked at already, and I talked about just now as well.
Yep.
Mutex contention is definitely an interesting one as well. In case it's not well known, and I think like outside of the Go community, maybe C++ engineers understand this, but like single-threaded environments like Node.js or often in Ruby, these things aren't used either. Maybe in Python, but mutexes are essentially a synchronization primitive where we can say someone has the exclusive right to some piece of memory. And this is great in terms of writing safe code, but it can also lead to contention when multiple threads want to, or Go routines in the Go case, want to write to the same thing. And that means that they're blocking each other and creating latency potentially in the system, or worse, maybe even deadlocks if it never gets freed, the mutex. And then the last one that we see is CPU time, which is something that we already looked at earlier. So literally, where was CPU time being spent in my process?
Awesome. Thank you for that. You are a wealth of knowledge. Right. So Matthias in the comments has double checked the release for 071 and confirmed that the cumulative value for formatting is indeed broken and will open an issue. There you go.
Great.
All right. Is there anything else that you want to look at before we deploy the microservice demo thing? Is there anything we've missed from the UI or functionality from Parca that you want to show off before we do that?
I think the only thing that we kind of just glanced over, but something that I was quite excited about because this was something that we didn't have in Prometheus for the very longest time, which is autocomplete of the queries. So if you go back and click on profiles again, we can see that we have autocompletion for the label names. And actually, behind all of this is an entire language of writing these queries, and it's very similar to the Prometheus query language, but we kind of have a real parser in the front end here that takes the query apart and does suggestions
Nice.
based on where your cursor is. Right now, it actually only the suggestions only work for label names as well as like constants, and you'll see what I mean by constants if you, let's say, choose instance and then equals or whatever really, and then you do two quotes after the equals, and yeah, now you can see that that comma was being suggested, right? Because that is logically the next thing that should follow after this. So yeah, I was pretty excited about this, primarily because I haven't written a parser since like my compilers class in university, I think. But yeah, I think this is pretty cool. And obviously, the next thing that we're building here is that we have label value completion as well.
Yeah, that would be awesome. I did appreciate
Yeah.
the autocomplete when we started clicking onto the boxes and stuff. So
Yeah.
being able to do that on the values themselves would be a really, really nice touch.
Yeah. Yeah. It's in progress. A lot of the plumbing actually already exists.
Nice. All right. So I prepared a small kind of microservice thing in Go that I found on GitHub. So this is by the user Harlow. And it's just like 4 Go-based microservices that display some hotels on a map. And they use gRPC to do communication, and I thought it'd be good to see profiles across that. Before I knew anything about Parca, in fact, while I was even pronouncing Parca wrong, a whole hour ago, is that I didn't know the compare feature existed. And now I'm kicking myself because we missed an opportunity to actually use it as part of the demo that I wanted to show. So I'm thinking that we're trying to be brave here, which never works out well for me. So the only thing I added to this project was a whole bunch of YAML to do the deployment here. I really naively used the latest tag, but I'm hoping if I do an image list, is that we'll still have the content addressable one that I pushed earlier. So I think I'm going to update this YAML to deploy the old one before I added the bug for you to find, to see if that can help us do it. There, okay. So I've injected like a little bit of CPU intensive code into one of the services, and we want to see if we can debug and discover that. So this is the fun bit though. The first time I built this, I built it without the platform argument. So this should be the one that won't work at all. Then, because it's an M1 Mac, it didn't deploy my Kubernetes cluster, which is not ARM64. So I think we need to deploy this one. Now, how do I get the actual SHA from that?
You might be able to check out the registry where you pushed it to, and we might be able to find just enough of the SHA. I think if you click on the tag, there's a history or something sometimes. Maybe only Quay does that.
All right, well, there must be a way to show the SHAs here. Yeah, digest, there we go. And we'll make sure this matches up. So the current one is 94D4, which is this one. Which means this one here should be my before I broke the code. So if I go into my Kubernetes folder, replace latest with the SHA. Do you need the @ symbol? I can't remember.
Yes, you need the @ symbol, and you actually need to write SHA to 365 : as well. Yeah.
Okay. And we want to do that in the start.yaml. I guess just I'm feeling how to said now. Sed-is search replace. Yeah, it should just be file name, right? Let's do front end on its own.
I think there might be a thing where, maybe the @ symbol or the colon does something with the regex. I'm never too sure either.
No, they not in the replacement side. If it was on the matching side, definitely.
I see. Yeah, you're right.
But there, I think it's all right. So this is just me not remembering said, which you just put the file, yeah. So I is inline. Maybe we need the E. There's the IE. There we go. Welcome to the said beginner's guide for idiots. I'm the idiot.
But now we have the colon before the @
All right, I'm going to open it in VS Code. Okay, so we just need that, right?
Yeah.
Yeah, I don't need to geo. Said failure. All right. This profile service. This. I'm waiting for someone in the chat to tell me what my mistake was, but sometimes it's just quicker to do it the boring way. So let's do a kube control apply star. What? Okay, dot. There we go. No, I can't even remember kube control. So,
Okay, maybe I got that wrong.
Well, it worked for front end. Oh no, because sorry. See, I told you whenever anything goes wrong, just blame me. It's always me. I forgot the SHA-256 on the other ones.
I see.
All right. I wish I had just deployed it straight up now, but if this works and we see the difference, I'll be very excited. And apply. Okay, that is going to work. Yeah, we can already see them starting to run.
Yeah, nice.
Now, because we have the server and the agent already deployed, if I do a port forward, we should be able to see. Okay, port, there we go. I know that's the front end. Well, I guess we probably. No, we don't need traffic yet. We can just. Parsa. We could just go to here and we should see data already. Wonder if I need to shut down the other one. No, cool.
Looks good.
So let's take a look at the default namespace. I got a new keyboard and I can't type. So cool. Is that right? Yeah.
Yeah, that looks right.
Yeah, so we can see Jaeger in front end. I expected to see a few more containers. Now it could just be that this. Oh no, I'm on the wrong cluster. There we go. There we go. So it could just be the sampling hasn't kicked in for the other ones, which started a little bit late. So if we hit search again, all right, we're getting more colors.
Yeah.
Cool. This application is nice and simple. We could browse to localhost on port 8080.
It could also be so if there's absolutely no CPU time being spent, obviously there's nothing to measure. So that could be what we're seeing as well. It depends on what these services do.
Okay. Well, every time I zoom around, this is the back end of this application is talking to each other and checking and searching for new spaces. When I click on these, it hits the profile service. So we should see in a little bit of time that we're going to get more information.
Mm-hmm.
However, I think if we just go straight ahead and deploy the broken one now and interact with it, we should see a hopefully spike in the CPU.
Yeah.
So let's try and keep those two running just now. And go back to here and undo. Cool. I-F go. Oh, Kubernetes.
Is it the wrong cluster again? Yeah.
I swear I know what I'm doing. I promise. All right. So we got some new containers coming up. We'll let that switch over. We'll let Parca do its thing, get some profiles in, and then we'll see if you can just guide me through the process of debugging which service is giving us some problems. And hopefully it works. Cool. All right. So we got a comment from Matthias. This is where the fun begins. I certainly wasn't finding my skills there particularly fun, but hopefully this works. Moz is telling me to use the hash symbol to escape the @char. I still don't think we had to escape the @char because it was on a replace side. But then I've just shown them my said skills are not exactly up to date. So we'll see.
It might be that @ can be used for selecting a grouping or something of the first.
Yeah, I mean, you could be right. I can't remember.
There are a lot of different.
I know
regex,
$sign allows me to
syntaxes,
pull
so.
things from the match, but yeah, maybe
Yeah.
you could be right. Okay. Let's click search. Okay, we're getting more data. So I need to report forward again. So this is the new version. So if I zoom in a few times, click a few buttons, and I guess we just kind of, oh, there we go. That might be related potentially. I think we should get a refresh every 10 seconds button. Is that a good feature request?
Yeah, actually, it's already in progress.
Nice. Okay. So we potentially have enough information to debug here. Do you want to kind of guide us what you would do if you were actually trying to work out what was wrong in this system?
So in this case, I want to say we're probably like we see this spike that we didn't see before, right? And I think I saw that the profile container is what was the contender here.
Mm-hmm.
So let's filter down by that container. So if you hit Shift again, you can click that label again. Yeah. So now basically you can go to your compare view.
This is, and I just want to point this out because if this is, are these colors to show different deployments of the same container?
Yes, exactly.
That's sweet. So I can actually already see exactly when this swapped over and then the contention happened on the CPU. So that's cool.
Yeah. And if there was a particular label that also kind of distinguished the two deployments, in this case, we don't really have that. We have the container ID, which we could, abuse for the same purpose, but ideally we would have a git SHA or something that means something to us as the developer. Then we could, once we go into our compare view, we could actually filter down to seeing only those points of data. But in this case, the just selecting a point in time will do the same. Will have the same effect. So what you can do is you can on the left-hand side select one of the profiles, maybe the one that has a couple of
I'm
points
just
of
trying to see
data
how
in
big I can get the graph. Okay. Give that 10 seconds or something. Sorry, what would you like me to click on there?
On the left hand side, let's click wherever that spike was on the blue line, and then we can compare that to a spike on the right hand side.
All right, we'll use what we have just now. So.
Interesting. Okay, so in this case, we're actually seeing something interesting. We can pause here for a second. We're seeing a bunch of memory addresses, right? And what we've just caught here is that Parca hasn't actually been able to keep up with all of the new data that we've been sending to it. And it does a process called symbolization. And one of the employees at Polar Signals, Kemal, he just wrote a fantastic blog post about what's happening deep down in this process. But essentially, the way that you can think of symbolization on a very high level is all of these memory addresses is what we actually captured from eBPF, right? So eBPF or the kernel really only sees a stack being built. And with eBPF, we're reading that entire stack. But we're from that kind of perspective, we're not actually reading the function names or something. We're only reading the offsets of that code in our binary. And that's basically what we're looking at here. And so hopefully once we refresh, Parca has had enough time to get to these memory addresses that have not been symbolized yet, and can put some meaningful names for us humans behind that. Okay, looks like something's wrong. I can't say yet what. Maybe we can jump over to not doing the comparison, and we can see if we can find any of the if we can find any symbols for the new container.
Okay, so if I just do this,
that's just the Parca one. I think
quite hard, yeah.
you probably want to filter it down to the default namespace. Yeah, looks like something about symbolization is wrong. Maybe we can check out the logs of the Parca server to figure out what's going on.
Yeah.
Some things appear to be working. We could see that the kernel space was actually correctly symbolized. If you scroll down here, we can see this is actually something that also is incredibly cool about using eBPF for this. If we were using a user space profiler only, like the ones that are built into the Go runtime, we would never be able to have this depth of detail, because from user space, we would never be able to tell the kernel stack that we're currently in. But eBPF gives us that kind of insight, which I think is really really exciting, because sometimes it is things that are that far deep in our infrastructure that we need to understand that there's some sort of, maybe, one of the most expensive things on Linux machines is this context switch from user space to kernel space or vice versa. And if we can detect that this is happening a lot, then that's also incredibly valuable performance information. So we were very excited when we got that kind of detail of knowledge for the first time.
Okay. There's no logs on the Parca server. Do we want to look at the agent, or do we want to
Yeah, we could have a look at the agent.
Is this going to work?
I think it's the canonical Kubernetes app labeled, so it should be app.kubernetes.io. Okay.
All right, I'll just do it. No. All right, I don't think we're going to get anything from there. We may as well do the last one since we've done 2 and 3.
Yeah.
Okay. So what happened here then is when we do the search and we're trying to look at this, is that what we get by default is this object notation for something that happened, and then Parca has to resolve that to a name or a symbol, and that process
Yes.
isn't happening here.
Yeah,
Okay.
so this is something that happens asynchronously in the background. When we upload the profiling data, we actually all we're uploading are these memory addresses. And then Parca tries to symbolize them with all of the new data that we're seeing. And it seems like for some reason this is stuck or it doesn't have the appropriate information that it needs for this. Again, I think this format would probably we can talk probably for 6 hours about how the symbolization stuff works. Here it appears to work. Not sure why
So it
this
could
one
be
works
the
and the other one
container
doesn't.
image I built. This is the Jaeger one, and the symbols are definitely coming through okay. But if we go to the container images that I built, now is there a way when I do a go build that I am disabling any
There
symbol
there
information?
are there are ways where you could potentially disable something like this, and that's very closely related to how this process works. So on a high level, if we think about what our binaries are made up of, they're in a format called ELF. Um, and an ELF binary has various sections that describe parts of the binary, basically. Um, Obviously, parts of it are executable code, but there are various other sections, and one of them contains something that's called dwarf debugging information. And this section, sometimes people strip out of their binaries in order to save space. Um, of the size of the binary, because the executable code will still execute fine without dwarf information, but you may be missing out on the ability to debug. And there are various case studies that all of the hyperscalers essentially have done, and they always ended up uh, coming to the conclusion that it's not worth throwing away this information, because
Yeah.
being able to debug is just always going to be worth it. Um, I
All
see
right.
you did add a couple of compiler flags, so this might be the culprit, but I don't know off the top of my head what -s and -w do.
Yeah, these just came with the Docker file for the project. In fact, if I just go here, may as well just do the spoiler now and show you. I haven't modified a Docker file. I don't know what those flags do either. They could very well, that -s being a strip, could be what's happening there. But I just decided to launch a Go routine that did a nice big loop. So that's why I've ever seen that thing. Uh,
Yeah,
oh well.
nice.
Still, I think we've seen a lot from Parca. I think we can all see the value that it brings to our infrastructure. I definitely do believe that if you have a Kubernetes cluster in production, that Parca should be part of that stack, because you just don't want to lose the type of information that we're getting here, especially when things go wrong and you need as much information as possible. And if you're deploying in a cloud native way frequently, multiple times per day, being able that compare feature is just golden. I had no idea we were going to see that, and I'm so impressed and so excited to get that running on my own clusters now. So thank you for that.
Yeah, my pleasure. I think the first time, and maybe Matthias remembers this. He's in the comments. The first time we like implemented this, we were so mesmerized by this. We like I think we spent like an hour just clicking around, understanding just Parca itself. Like what was the memory difference here and why? Why was this? What's the CPU spike? And just like understanding that depth down to the line number is just not something we've never seen before.
Yeah,
So yeah, I share the enthusiasm.
sweet. Matthias is in the comments saying that -s is probably the culprit. So well, I'm sure we'll do more demos in the future and we can take a look at that. I'm curious, we'll finish up now in the next few minutes, but kind of what your thoughts are on what's coming next for Parca, what it takes for Parca to reach its next milestone, whether that be like a 1.0 or something else, and other crazy ideas that you've maybe got. So let's start with what's next for Parca.
Yeah, so I think the most important thing for the community that we're working on with Parca is actually on the storage side. As you can imagine, we're dealing with a whole lot of data, and it's not easy to deal with that amount of data, making it queryable as dynamically as we do with Parca. And of course, the larger the scale, the harder this gets. And so we're working on kind of a new storage iteration that's going to allow us to scale this to the size that we intend at the query latency that we want. So as we saw, the demo worked great, but if once we go into the hundreds or thousands of nodes with thousands of containers, it gets more difficult to query that data efficiently. And so we're actually building an entirely custom columnar store just to solve this problem. So that's something that I think is really important to the success of this project, so that we can kind of scale the entire idea. So yeah, that's something that I'm also personally very excited about, because I think the design is open. You can find the design on the I think it might have only been discussed in the Parca office hours so far, but it's open.
Nice. Do you see a future where Parca integrates with autoscalers on Kubernetes to be able to, I can see like the vertical pod autoscaler and being able to modify those limits based on what Parca sees, and for that to evolve over time across versions, even maybe to the point of hooking into remediation systems like Captain and actually reverting a deploy based on bad behaviors or performance.
Yeah, 100%. So as I said, the hyperscalers have been doing methodologies like this for almost a decade. And actually, eBPF is kind of the reason why this is accessible to us now. Hyperscalers have been maintaining their operating system versions themselves for a long time. And that's why they were able to do integrations like this at a very low level that just the rest of the world wasn't able to do. So like eBPF was really kind of a godsend for this. But what I was trying to get to, Google has actually written a couple of papers where they described exactly what you just said, that they use this type of data for scheduling decisions in their orchestration system Borg. And they do various other optimization techniques. One that I'm particularly excited about is something called profile-guided optimizations. And this is kind of a technique that has existed, I believe, in my research. I found the first kind of mentions in the 1970s, and the premise is really simple. Because we understand how our programs are going to be executed in real life, we can make opinionated compiler optimizations for exactly those situations. Optimizations that may not generally be a good idea, but because we know how this code is going to be executed, we can make opinionated optimizations. And the great news kind of is these things do already exist in all major compiler tool chains. And as a matter of fact, the very next version of Go is going to ship with profile-guided optimizations possibilities as well. So the great news for the Parca project is kind of, we don't even need to build these mechanisms into compilers. They already exist. We just need to be able to export this data in the format that these compilers expect. And then the hope that we have from all of this is that magically, just by giving your compiler some of this data that you're collecting, hopefully anyways now, your programs just magically get faster, better, less resources.
Awesome. That is all extremely exciting, and I can't wait to follow along with the Parca journey and just see what cool things come out of this over the next 6 months and longer. So thank you so much for joining us and guiding us through this. It's been really cool. I think it's awesome to be able to see these new techniques and tools come out and make everything, well, hopefully make all of our lives that little bit easier. Any final words before we say goodbye for today?
Just my final words are, please try out Parca. And join us on our Discord server if you have any issues or any questions, feedback, anything. We're more than happy to help you through it if you have any issues or work through feedback. We're always happy to have any kind of feedback, and hope to improve Parca together with the community.
Awesome. Well, thanks again for joining me, Frederick. Having a wonderful day, and I'll speak to you again soon.
My pleasure. Thank you for having me.